Testing, testing. Testing, testing, testing. Testing, testing. Alright. So I am going to do some more testing, LeetCode problems. Or I'm going to try to. So I'm just going to pick one by random. Go. Oof, hard, okay. Okay, so count the number of special subsequences. A sequence is special if it contains a positive number of zeros followed by a positive number of ones, then a positive number of twos. For example, 0, 1, 2 and 0, 0, 1, 1, 1, 2 are special. In contrast, 2, 1, 0, 1 and 0, 1, 2, 0 are not special. Given an array nums consisting only of integers, return the number of different subsequences that are special. Okay. Subsequence of an array is a sequence that can be derived from the array by deleting some or no elements without changing the order of the remaining elements. Okay, so two subsequences are different if the set of okay. That sounds kind of tough. So we need to get all of the possible subsequences and then check them, right? Or we could do, I think, okay, so I'm thinking like, so say we have so input there, but those are that's the same. So I'm thinking like maybe something recursive would work here. Yeah, this one's kind of tough. Figure out, maybe we should start with the easier one to warm up. Here we go. Given an array of string words, return all strings in words, which is a substring of another word in any order. So given string words at I is a substring of words at J if it can be obtained by removing some characters. Okay, so that's, we can do that pretty easy. Check that pretty easy. So return all strings in words which is a substring of another word. String. It's a substring of if it can be by removing some characters to the left or right side of. Okay. Cool. Okay, cool. Alright, yeah, this one's not bad. So, what we'll say is, for it's the same idea where we have, well, actually, yeah, okay, so yeah, we have to do it. It's not exactly like yesterday where we only have to check the ones after, because just because mass isn't in as doesn't mean as isn't in mass, right? So we gotta basically pop out, when we check each one, we gotta pop it out, and then we gotta check it against the rest of the list, right? So, so what we could say is, let's loop through it. We'll say I is 0, while I is less than length of words. Then what we'll say is we'll say we'll say we're checking to see if it's a substring, or the one that we're on is just going to be, we'll just say, so first we'll say, we'll make a copy, we'll say, so we don't alter the original list, we'll say words dot, so array equals words dot copy, and then we'll say, the substring that we're checking to see if is in all the other ones is going to be array dot pop at the index that we're on, and then for we'll just say for string and array if, and we need to return all of the strings that are substrings. So we'll say all the substrings is the empty array for string and array if sub is in string, then we want to, so if it happens more than once though, you don't add it more than once, right? Say it. Is there like a C expected output? We'll see. If I need to fix it, I'll fix it. Well, anyway, if sub is in string, then we'll go, or I could probably make it a set if I wanted to do that. I could make it a set so there's no repeats and then just cast it as a list at the end. This is guaranteed to be unique, right? Does that mean, no, it doesn't necessarily mean that it won't show, that it won't be a substring more than once, right? We'll see substrings. The append, and we'll append the sub, and then say I plus equals 1, and then return substrings, right? Let's see what happens. Unanswered. Yeah, okay, so I did it more than once. So we'll say substrings is a set. Python add to set add. So just go set and we go dot add. So go dot add that, and then we'll return it as a list. There we go. Cool. All right. Time we at now? We got it. Cool. That's not too bad. Let's do another. Let's try another random. Custom sort string. You are given two strings, order and s. All the words of order are unique and were sorted in some custom order previously. Permute the characters of s so that they can match the order that order was sorted. Specifically, if a character x occurs before a character y in order, then x should occur before y in the permuted string. Return any permutation of s that satisfies this property. So CBA That's weird. Okay. So what we gotta do is so we could probably, so basically the index of the character in order is like the priority level of the character s, right? So basically, would it always be the case? Okay, so but it would, I think it would always work, right? It would always work if what I did was just basically moved everything in S, or moved the corresponding characters in S to the index that they're at in order, and just kind of push it, like if I popped and inserted them until that was like, find the index. So say we go order, and we like find the index of C, we pop it out of where it is and then put it at the index it is in order, and then move on to B, we pop it out, and just basically do that, check every single one, see if it exists in the string. If it does, then to push it into that. But the only problem is that if it's later, like if there's some letters that weren't in there, I might put it at a little index after. So then I gotta just kind of loop through order, I think, and only increase the priority if, or increase the index I'm going to put it at in S if it existed. So we'll have like two things. So we'll basically have like so we'll have like insert, we'll have index, and we'll have like insert index, right? So we'll just say like I equals 0, insert I equals 0, and we'll go while I is less than I'm gonna alter. I think when you pass a, I don't know, you pass a string in it. Wait, I can't pop off a string anyway, right? So I'll have to cast it as a list first anyway. So we'll say so we'll say string list is equal to, and it's going to be list S, and while I is less than the length of order. Am I doing order first? No, you're doing S. You want string list, yeah. So then while I is less than length of order, we'll say if order at I is in string list, then we're going to go to pop, we'll pop, we're going to pop off string list at we want to get the index. Pop index equals list.index of order I, and then we want to string list.insert pop index. So we're gonna oh, but insert it where? Okay, so is it index and then element, or is it element index? I think it's index and then element, right? Insert. It's yeah, insert index and then element. So the index is gonna be insert index, right? And then only if we do this, then we want to increment insert index, right? And then we'll say I plus equals 1. So are we? And then we want to just believe return dot join stringless. So what we're doing, we're gonna go through. We make this into we make this into a list, and then we go through this. If it's in there, then we pop it, or we find the index to pop it out, and then we want to insert it wherever, yeah, like near the front, or just wherever's next at the front. And then, so the pop will go first because it's inside of there, so it'll pop it out first, and then it'll insert it. We're gonna increment insert I, and then we'll go I plus equals 1. And then when you join those all together, it'll turn it back into a string, and yeah, should work, I think. Cool. Okay, so what's the problem? We got KQEP. KQEP. So that character is supposed to keep that. That character is supposed to keep that precedence? Huh. Okay. Okay, I guess that makes sense. So then what we can do, probably to fix that, what we can do is we can say, we'll pop all of the ones off first that have. So let's say, we can make like a list of pop indices, and then we could say, so basically instead of this, what I can do, I think, if it's in there, so let's comment this out for a second. Okay, can you not do that? You want to put it, okay, there. So what we want to do is we could say that we'll have pop indices. I know. Yeah, we could. How about we just do this? We say while order at I and stringless. We'll go we'll keep a list of things to insert, and we'll say, well, order if I was in stringless, we'll go, we'll do just like that. We'll do pop indexes like that. And then we'll do to insert dot append. And we'll go so we'll pop all of these up and put them onto that insert list, and then we'll go while there's still stuff in there, while there's in the stuff in the to insert list, we'll do stringless insert I. We'll go to insert dot pop, and then we'll go insert I plus equals 1. Okay. That work? Help if I spelled things correctly. Cool. All right. Not the fastest or the best memory usage, but you know, it's Python, so. Now where are we at? 30 minutes, okay. Try like 1 or 2 more maybe. Check if a binary string has at most 1 segment of 1s. Given a binary string S without leading zeros, return true if S contains at most 1 contiguous segment of 1s. Okay, so there's, meaning there's at least 2 1s in a row somewhere. So I could just go like say I have s equals, I go s dot index of 11. But if I had s equals that, and then did that, okay, so error in that case. So I could do like a try catch maybe, if I do a try catch on index, and if it doesn't, if 11's not in, because like, yeah, it's basically is there an 11 in the string somewhere, right? Because that's what you mean by a contiguous segment of ones, right? At most, so that there's more than one in a row somewhere. So I could go like, I think the way that try catch. So I go like let's say Python try catch. Try, okay. So we'll say try to do so if this works and we don't get kicked into the exception, right? So if I go s dot index of 11, and catch, or no, accept and then what's the error for index? I know, index. It's not what I mean. Catch, what's the exception if you did, or what was it? I just did it. Value error. So go accept value error. Value error. Right? And then we go return false. Try it. Okay. Why would that be true? I'm struggling with it. What does this mean? One contiguous at most Okay. So all the ones have to be together is the thing, right? So that's what the problem says? Okay. So anywhere the ones are without leading zeros. So basically all the ones have to be at the front. So you could just go so actually this isn't terrible. This is like what we started here isn't terrible. What we could do is turn this into just this. But we want to do we want to make a new string, and the string is going to be starting from where the first 0 is. So we're going to go first 0 index is going to be at so we're going to want to try and catch that too, because if there's no zeros, then we just want to return true, right? They can't have a leading 0, so we can't just have 0. There's no way we can get 0, because that would be technically a leading 0, right? So so there's always going to be a 1 somewhere. So if there's not a 0, then we can just return true right away. So we'll say, we'll do a try catch with this as well. We'll go try first 0, and then catch or accept. And first 0 is going to be s dot index of 0. Right? Except value error. Return true. And then so then we're going to say, what we could probably do, we could just say s equals s from first 0 onward, right? And then if there's another 1 somewhere, then we want to flip these. We want false. But if there's nothing else, if there's only one contiguous segment of 1s, then we want to return true. Cool. All right. Oh, this is comparing against other Python solutions, though. So this, yeah. So the other one was kind of, this one came out all right, but the other one was pretty bad even compared to the other Python ones. All right, let's see. Should I do one more? Okay, I guess I'll try to do one more. Let's see what we got. Minimize Hamming distance after swap operations. You're given 2 integers arrays, source and target, both of length n. You're given an array allowed swaps, where allowed swaps I equals AI, BI indicates you're allowed to swap elements. At index AI and BI, you can swap elements multiple times in any order. Hamming distance is the number of positions where the elements are different. Okay, this is another one that sounds like a pain. This sounds like a pain. Oh, this says mulligan that one. Okay, given two integers a and b, return any string s such that s has the length a plus b and contains exactly a letters and exactly b letters. And such that you can't have three a's in a row and you can't have three b's in a row. And it is guaranteed so that they're both going to be between 0 and 100, and it's guaranteed that the string will exist. So what we could probably do, I think the easiest way to do this probably would be to find whichever one's bigger, right? Whichever one well, if we have twice as much, so we gotta check if we have twice as many. So if we have more than twice as many, then we want to spread it out between every two. But if we only have like twice as many, then we can just alternate them, right? Say we have, so here, for example, this is exactly twice as many. So like, if you have exactly twice as many, or less, then we can just alternate the A's and the B's, I think. Or what I could do is go through alternate them. I'm thinking, okay, so here's like an algorithm I'm thinking, maybe. So we have like A equals, could we do it with A equals like 10 and B equals 4? So then we have, so if we start with just while we can, or we'll just start with A, B, right? A, B, and then we've used up all those. Then we have A is equal to, because we've used 4 A's, 1, 2, 3, 4, so we have 6 left, and then B is 0, right? So what we could do then is go back through and append or insert at the index of each B. Yeah, because it's gonna pushes it to the right? So we inserted the A at each index of B then, from this point, so we go, so we could, while we're doing that, I guess we could maybe keep a, or actually it's just gonna be it's gonna increase with each, unless we do it from the back, which we could keep a list or something like that. Yeah, we could go like, so if we kept a list of the indices, we could go like, that would be 1, 3, 5, and 7. And then if we popped them, or if we inserted at those indices one at a time from the back, popping it off, then that would put it in the right order. And then we just kind of try to append whatever's left at the end. But what if there's, so you're going to want to start with, you're always going to want to start with whichever one's bigger, right? Because you can fit more of those in because you can put them on the front and on the back, right? Or I think that would be the case, wouldn't it? Unless, yeah. So, and then this is just basically the odd, is basically always just going to be the odd numbers counting from the end length decrementing down to the front, right? So we don't necessarily, we wouldn't, to save on space, we could actually not even make that list. We could just go off the length, and then I wonder if that'd be faster, because we have to, because then we could just check if it's odd on the way back. If it's odd, then insert an A there if we have more A's to insert, or whichever one's bigger at that point, right? I don't know. I'm trying to figure. Do you think would it be faster to do, or would it be better to do that, or just to keep the list? Because then the list is just you don't have to do that like modulus division on the way back the whole time. You just create it on the way, so it's a little bit. I think it's gonna use a little more space, but it's gonna take less of time. Maybe we'll see. We'll try it with the list first. And then so then we would go and we'd pop the end one off and insert at the end index each way. So that way we're not inserting at the beginning, so the indexes that we're inserting at aren't going to get pushed forward while we're doing it. And that could go. And then just throw all the rest at whatever's left on the end, right? So we go, then insert, yeah. So then we insert, basically we go here, and we insert an A here, and then 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 we'd have A equals 2, B equals 0, and then we could put the last two A's at the end, right? Then just whatever's left, just throw it at the end. I think that's the algorithm I'm thinking. So let's try that. Okay, so so we'll start by making a list, and then okay. So then so we'll say start with is max AB, and then if equals is equal to A, then what we want to do is so start character is going to be A. Else start character is going to be B. And then okay. So if it ends up being, so start with is whichever one's bigger. And then if it's A, then the alternating one's going to be B. If it's B, then the alternating one's going to be A. So what we basically want to do then is while alt, we want to do it's like, I guess you give it another list. So we go extend, and we want to go A. We want to do so extend, and we want to go while alt, I'm going to extend start char alt char, and then we want to go and subtract start with, and we go alt minus equals 1 as well. And then and we'll say insert indices and how do I start with Okay, well, no, actually, it's just the odd ones, right? So, we'll just do that. We'll just do it by number. We'll just do it by number. And we'll go. So we'll go. End index is length of string array -1, and then we'll go end index is greater than or equal to 0. What we're going to do is if and index modulus 2 is not equal to 0, meaning it's odd, then we want to insert at that index, and we want to go let's just try it like this first, minus equals 1. I know I could skip skip every other one and probably make it better. And then, so then, if we do that, so we, insert all of that, and then, well, then we'll just say, well, oh, I want to go minus equals 1, and then finally, while start with, we want to string array append start char, and then minus equals 1. Finally, we want to return dot join. Okay. Interesting. Crisscross. No. Time limit exceeded. Lovely. So we want all the odd ones, so we'll say if index modulus two is equal to 0. If it's an even index, then go but it's actually impossible, right? It's actually not I don't think it's actually possible that it could be an even index. No, because you're adding 2 at a time, so it can't possibly be an even index. So then we'll just say, how about just we don't check this. And we just say minus n index minus equals 2. So that still works. It's still a time thing. All the inserts are probably not helping. So what's a better way of doing? What would be a better way? Faster. So I guess you gotta do the math, like if it's, I was probably on the right track the first time. I was thinking, like, if there's twice as many, then you want to do 2 every 1. But if it's less than that, then you want to alternate them. Then it's just not as. I'm just worried about like edge cases. It seems most straightforward, but obviously it's not the fastest way to do this. It's clearly not fast enough even. Sure. Yeah, well, I think I might come back to it. I might think about it a little bit off camera, and then come back to it next stream, potentially, or I might just start with a different one. I think the logic's right. Is just yeah, this is slow, and I would expect it to be slow because it's doing a lot of inserts. So, yeah, I'll think about it. I think it's just a matter. I think what I was thinking the first time. I should have just gone with what I was thinking initially, which was like, if there's more than double of the characters, then to do 2 for every one. But if not, then just to alternate them and then stick the rest on the something like that. But I just got to think it through. I'll sit down with a pen and paper and then come up with an algorithm. I'll come back to it. I'm gonna end the stream for now. Thank you anybody for watching if you've been watching, and I'll get back to it next time.